The video game Portal is a puzzle game built around a sci-fi device that can create a portal connecting one place on the wall or ceiling or floor to another, and portals are great for cooking up paradoxes. I already made a video about a particularly popular paradox, and also about how the portals might actually work from a physics perspective, but oh boy, are there more interesting portal paradoxes. Okay, so objects entering one end of a portal with a certain speed leave the other end with the same speed, and if the portals aren't oriented in the same direction, then the object will exit in the new direction, but the speed will be the same. In my first portal paradox video, I argued this should apply regardless of frame of reference, so the orange portal moving towards a cube is the same as a cube moving towards the orange portal. That is, both cause the cube to shoot out of the blue portal with the corresponding relative speed. Obviously, portals are fictional and there's no correct answer, but the cube shooting out of the blue portal makes the most sense given the possible ways portals could work within the physics of our universe. But there's another paradox hiding in the middle of this one. Literally, what would happen if the orange portal stopped halfway? Does the cube stay put? Does it tear itself in half? Does it shoot out of the blue portal anyway, pulling itself the rest of the way through? Or something else? I'll give you a second to pause and decide what you think. Again, there's no correct answer, portals are fictional and you can imagine them to work however you like. But for physically realistic portals, I think the best way to analyze the portal stopping halfway paradox is to instead imagine there are two cubes attached by a rope, and the orange portal stops between the cubes. In this case, the top cube will unequivocally shoot out of the blue portal at full speed before yanking the rope taut and pulling upwards on the bottom cube. If the rope is weak, then it'll break, but if it's strong, then it'll accelerate the bottom cube and slow down the top cube, so the cubes will both shoot out of the blue portal, but at half speed. So if now the orange portal stops halfway through a single cube, then if the cube is super fragile, it should tear in half, but more likely it'll just shoot out of the blue portal with half the speed. If the portal stops a third of the way through, then the cube will shoot out with a third the speed, and so on. Paradox solved. The next paradox is a bit more subtle. What if you try to sandwich a cube between two portals? Does the cube disappear? Do the portals bounce or stop? Or something else? Again, I think a change of perspective is helpful. Imagine instead that you extend a piston through the blue portal. Eventually it comes back and hits itself from behind. The piston can't keep extending into the portal because there is no inside of the portal. Inside the blue portal is outside the orange portal, and vice versa. Everything always exists outside the portals, and there's nowhere to hide. At this point, one of three things could happen. If the piston is weak, it should crumple, the same as if it were pushing against a solid wall. If the piston is rigid and the portals are super heavy, then the piston will just stop expanding, since it can't lengthen anymore and it's pushing against itself. But the orange portal is clearly pushing the piston out of it to the right, so Newton's equal and opposite law of motion means the piston is pushing the orange portal to the left, kind of like what happens when you throw a ball. Similarly, the blue portal is somehow absorbing the momentum of the piston entering it, and so should be pushed to the right, like what happens when you catch a ball. So if the portals aren't heavy, and aren't on super heavy objects, then the logical, if weird conclusion is that the portals themselves get pushed apart. Newton's laws also apply to the paradox of sandwiching a cube. The blue portal moving towards the cube causes the cube to emerge from the orange portal like a piston, until the cube hits itself. At which point, if the cube is weak, it'll crumple, but if it's strong, the portals should stop, or even get pushed back apart, aka they'll bounce. I should say that neither of these paradoxes is my original idea. The sandwich portal paradox was sent to me by somebody who tried it out in a sandbox version of the Portal video game and got some very trippy and non-physicsy glitches. And the halfway through the cube paradox was in fact posed to me by the Portal physics and rendering programmer on the team that made Portal 1 and 2. Apparently, they thought about having moving portals in the game, but for various reasons decided not to. Which is lucky for us, because that means we don't actually know how moving portals officially work, and instead, we get to hypothesize and debate and analyze portal paradoxes to our heart's content. Another thing you might want to debate is your favorite way to draw molecules. Do you prefer ball and stick, structural formulas, skeletal, ribbon diagrams, space filling, or maybe you're into the simplicity of a Lewis dot diagram? Whatever your preference, you can learn all about the pros and cons of each of these molecular representations on Brilliant, this video's sponsor, where we just launched a new and very special course created by Ever Salazar, Minute Earth illustrator and molecular representation fanatic. Can I just say, I've never seen such beautiful molecules, and you should definitely go check them out. Which you can. You can sign up for Brilliant for free at brilliant.org/minutephysics, and the first 200 people will get 20% off an annual premium subscription with full access to all of Brilliant's courses and puzzles, including Ever's beautiful molecule course. Again, that's brilliant.org/minutephysics. And thanks to Brilliant for letting us take over for a little bit.